Hello, young lovelies. This PowerPoint is going to go over the skeletal system physiology. So we have gone over the skeletal system anatomy. That's what we've been doing, and we saw where the bones are and what their names are. And now it's important to learn about what's actually happening inside the bone and how the bone works. All right. Bones are alive. Can you believe that? They are alive. They consist of bone tissue, cartilage, dense connective tissue, blood, and nervous tissue, which we know that tissues are made up of cells, right? From our song, we know that cells make up tissues. Well, cells are alive, and therefore all of these other tissues are alive as well. Now, some functions of the bone. So, meaning, what does the bone do? 1, it acts as points of attachment. For what? Muscles, right? Muscles attached to the bone, which allow us to move. It also helps support and protect. Think about like the rib cage. If we think about the rib cage, we can think about the spinal canal. So we have the vertebrae that are protecting the spinal cord. They house blood-producing cells. Holy cow, did you know that the bones produce blood? That is where blood comes from. If you ever thought about it, that's where it comes from. They also store some inorganic salts, and they form passageways for blood vessels and nerves. So ways for blood vessels and nerves to get from one point to another. Okay, so how do we classify bones? Bones are classified according to their shape. So things like the long bone, those are going to be things like your femur, your ulna, your radius, your tibia, your fibula, all that have long axes and expanded ends. So look at, well, like here in this picture, you can see it has a long axis and an expanded end. Then we have our short bones. Short bones are cube-like. Those are like your carpals and your tarsals. Remember, carpals are the wrist bones, and then the tarsals are the bones of the ankle. Then we have our flat bones. These are flat plate-like structures. So that's going to be things like your scapula, your skull bones. Anytime you have something that's flat with really broad surfaces, that's a flat bone. Then we have an irregular bone. The biggest one of this one is the vertebrae. Like, look at all these vertebrae over here. They're irregular. They're not necessarily round. They're not long. They're not short. They're just kind of irregular. So they're usually connected to other bones, meaning bone to bone to bone to bone, right on top of each other. And then finally, the last type of bone is called a sesamoid bone or a round bone. And the biggest one that we know here is called the patella, which, remember, is the kneecap. All right, so let's talk about the parts of a long bone. We have the epiphysis. Now, the epiphysis are the two ends of the bone, here and here. Those are what articulate. Articulate just means to come together. So if you articulate with somebody, that means you come together with them. So where bones articulate with each other is called the epiphysis. Together, they would be the epiphyses. Spongy bone is numerous branching planes. So like if you look in here, it almost looks like a sponge itself. The articular cartilage is, we find those on the ends of bones here. This is a lot of times what wears away in people who have arthritis and causes problems, but it's the cartilage that kind of acts as like a shock absorber at the end of the bone. Then we have the diaphysis. The diaphysis is what we refer to as the shaft of the bone. It's the longer, skinnier part. Inside the bone, we have the medullary cavity. So that's right here. So when you actually cut a bone in half, it is not completely solid. And can you think of a reason why you wouldn't want the bone to be completely solid? Think about that in your head right now. Why wouldn't you want the bone to be completely solid? Think about like, oh, if we want it to be really strong, then don't we want it to be completely solid? Well, the answer is no, and that's because otherwise our bones would be really, really heavy. And if our bones are really, really heavy, they're going to be really hard to move around as well. So, the spongy bone is pretty light, and then we have this medullary cavity, which is actually hollow, and it's filled with something called marrow, which I'm sure you guys have heard of. At some point, people talking about bone marrow transplants and things like that, which we'll talk about in a second. Then we have the endosteum. The endosteum lines this cavity on the inside. Then we have the periosteum, which encloses the entire bone. So that's the thing like on the entire outside of the bone. Think about the word peri, like the perimeter of something. Like the perimeter is the way outside. So that's the same thing on bone. The periosteum is the way outside. Because remember, osteo means bone. So anytime you see osteo, that means bone. And then finally, the compact bone, that is the tightly packed tissue in the diaphysis. So that's going to be like this skinny part right here that I'm in blue. Right here, that is tightly packed bone, like in here, until it gets to the hollow part. But on either side, this blue part is tightly packed, and that's the compact bone. So here's just another picture of a long bone here that you can see a little bit more detailed parts of the compact bone in here. You can see the spongy bone in here. You can see how there are blood vessels and nerves that run through here. And then finally, you can see this bone marrow that we're going to talk about in the center. Okay, so some parts of the bone. There are these things called processes. Processes are bony projections that that provide sites for ligaments and tendons to attach. One of the most famous processes right here is called the mastoid process, and it's where actually there's a muscle that we'll learn about called the sternocleidomastoid, and it attaches right there. We also have grooves and openings. These grooves and opening provide passageways for nerves and tendons and blood vessels to work through. So if we see through here, we can see that there's a patellofemoral groove. That's where the patella sits inside the femur right there. There's a groove, and it allows for the patella to move back and forth freely. Then we have sinuses. Sinuses, we talked about a little bit within the skull. You could probably see them when we were identifying the parts of the skull. But the reason why we have sinuses is because it's actually a cavity. If you look here, and sometimes when you're sick, you can actually like feel a lot of pressure in those areas. And the reason is when you're sick, those cavities fill with mucus and can make your head actually feel very heavy, because the purpose of the sinus is to make it feel light. It's to lighten the weight of the skull, because if you are, walking around, you don't want a heavy head. So your sinuses help lighten the weight of your skull. But again, when you're sick, sometimes, that kind of gives you that heavy head feeling. It also gives resonance to your voice, just kind of how you speak. Resonance to me means that's why when I pick my head up, I don't have to look and see who's talking. I know who's talking just based upon the resonance of their voice. That's also why, when people are always like, oh, you sound really sick. The reason is if the sinuses fill with mucus, it changes the resonance of your voice, and that's how people can tell you're sick without even really knowing. They also filter, moisten the air that we breathe. They remove unwanted particles, dust and dander and things like that. And then finally, these fontanelles. These are areas of incomplete intramembranous ossification, which basically is a big term for the soft spots that we talk about in a baby's head. If you look here, and here are your big fontanelles. This is the soft spots that when a baby's born, the reason that we have them is because we need the baby's head to be kind of moldable, meaning we don't want it to be completely solid when it's coming out of a woman's vagina, because otherwise that would be a pretty tough delivery. That's why sometimes some of the newborns come out and they seem to have a cone head. It's because the bones of the skull are not completely formed. There's actually some give to them and some cartilage, like kind of in these areas, that allow for the head to mold a little bit and come out a bit easier. The chart on page 142 of your book you will be responsible for, so make sure you open up your book to 142 and check that out. All right, so let's talk about vertebrae. We should know this. We're going to roll through this part really quickly. We know that there's 7 cervical, 12 thoracic, and 5 lumbar. You remember, you eat breakfast at 7, lunch at 12, dinner at around 5. And we know that the first 2 cervical vertebrae have special names, the atlas, and then the second one, C2, has the axis. And the atlas is what allows us to nod our head yes, and the axis allows us to pivot or rotate our head. If we look here, we have some different parts of the vertebrae. So here's the body of the vertebrae. The vertebral foramen is right here, the hole. The lamina is this part up here. And then this is the spinous process. This is what's coming off the posterior side of the body that people see, kind of those little spiky things coming out. Those are called the spinous processes. All right, so when looking at a skeleton, how can we tell the difference between a male and a female skeleton? Well, one, we can look at the skull, right? The skull in a female is going to be smaller, lighter, rounder. The pelvic girdle is going to be lighter and a bit thinner. The pelvic cavity is going to be wider but shorter in a female. The sacrum a little bit wider, and the coccyx, which is the tailbone, a little bit more movable. So if you kind of look at all those things together, you can determine the difference between a male and a female skeleton. All right, so how do bones become bones? Bones form by replacing existing connective tissue in one of 2 ways. So the first way is through intramembranous bones, and those originate between sheet-like layers of connective tissue. And the other one is endochondral bones, and those begin as masses of cartilage that are later replaced by bone tissue. The best way to think about these are with like you would with a baby. This picture down here is very good. It shows some of these things. Intramembranous bones are going to be like these bones of the skull, like up here, meaning that there are these sheet-like layers of connective tissue, sheet-like layers of connective tissue that are formed there. And then the endochondral bones are going to be more like your bones, your long bones of the body. So look at this baby, this infant's radius and ulna. These are masses of cartilage, and then later they're going to be replaced by bone tissue. So they're soft right now. That's why a lot of times when they say that when an infant, like falls out of the crib, or if an infant, gets dropped or something, they don't typically break anything. Reason being, their bones are not formed to break. They're still really, really soft and pliable, which is why you also have to be very careful, because their bones are not formed to protect the body like ours, like adults. All right, so osteoblasts are bone-forming cells. So I always say B, B. Blasts build bone. Blasts build bone. The process of this happening is called ossification. So that's the formation of bone. So ossification is the process of bone hardening. So if I said, what was the process of bone hardening called? You would say ossification. If I said, what cells build bone? You would say osteoblasts. All right, so within those endochondral bones, remember, like those were the long bones of the body, like radius, ulna, tibia, fibula, those ones. Those endochondral bones have something called an epiphyseal plate. The epiphyseal plate is also called the growth plate. People refer to that as the growth plate. And these are layers of young cells undergoing mitosis. Mitosis, remember from biology, is the dividing of cells to produce new cells. So what happens is, as this plate thickens, as more cells divide, the plate thickens, and then the bone actually gets longer. So if you look right here, this plate is going to thicken, and then it's going to make the bone longer, hence your growth plate. That's what you can see in an x-ray, actually, of people. If you look at it and there's the plate is still open, we know that you still have room to grow. So in theory, right now, we could take you to get a full bone scan, and we could see your epiphyseal plates. And if your epiphyseal plates were still open, we know that you still have room to grow. If they're closed, then we know you're done growing. Now, this is an interesting part to know. If the epiphyseal plate is broken, damaged, what could happen is the bone can actually not grow. So it's very, very important that injuries of young people are taken care of with special concern, because if the growth plate is actually fractured, or the area around a growth plate is fractured like this, what can happen is the bone can stop growing. So think about if you have an epiphyseal plate fracture on your left humerus. Well, if you don't take care of it properly, your left arm could be very much shorter than your right arm, and that would not be good for life. All right, so speaking of fractures, and let's get rid of this myth here. A fracture is a break in the bone. There is absolutely no difference. So a bone fracture and a bone break, the exact same thing. I always hear in the training room people say that I didn't break the bone, I fractured it, or I didn't fracture the bone, I broke it. It is the exact same thing. Don't be that person in life. All right, so we classified the fracture by cause and by the nature of the break. So there's some major steps for fracture repair. The first one is that blood escapes from the blood vessels and forms a hematoma. Hemat means blood. Oma means tumor, so hematoma together is a blood tumor. So basically blood comes and forms a little blood tumor over the area. Then the spongy bone is going to form in the regions close to the developing vessels, and fibrocartilage forms in distant regions. So basically, the spongy bone is going to start to form to reconstruct. Then a bony callus is going to replace the fibrocartilage. So the cartilage is going to be soft, and then finally it's going to get a bony callus, which is going to be a little bit harder. And then finally, osteoclasts remove any excess bone tissue, and then they restore new bone, much like the original. Now, remember we said blasts build bone? Well, now we have clasts. So I always think of the osteoclasts, they clash together, and when they clash together, that means that they eat up excess bone tissue. They get rid of it. They break down. So the osteoclasts break down the bone tissue and take it away, whereas the blasts build bone. All right, so this is a great picture here. We can see that this fracture right here of the tibia and fibula, you can see here's the fibula broken, here's the tibia broken. This is a major, major fracture. But this is how it was at the beginning, and then you can see this is in the healing process as it starts to come together. If you look here, here's that hematoma forming on the bone, and then here's that soft callus, and then here's that hard callus of spongy bone, and then finally here's where the clasts came in, and they ate up all this rest of this crap and made it nice again. All right, so bone actually makes blood cells. That's a huge, huge part of their job. They make blood cells, which, remember I said the word hemat means blood? Poiesis means formation or beginning of. So hematopoiesis is the formation of blood. It's before birth that takes place in the yolk sac. After birth, the liver and spleen do it. Later on in life, after the bone forms, then the bone marrow makes it. Like as your bone forms and it becomes solid, your bone marrow makes the blood cells. So bone marrow, two types. There's red bone marrow and yellow bone marrow. You might have seen this in actually like animal bones that you eat. So if you think about bones that come with like people use it for soup, and they say that the soup bone makes the soup have better flavor. So let's think about why this would be. Why would you put bones in your soup to give it better flavor? How does that work? Well, the answer is it all lies in the yellow marrow, because guess what? The yellow marrow stores fat. So if you put a bone in the soup and you boil it, that fat is going to be released, and then that fat causes the soup to taste better because it's fat and it gives it better flavor. So that's what the yellow marrow does. Yellow marrow simply stores fat. Now, the red marrow, this forms the erythrocytes, which is the red blood cells, leukocytes, which is the white blood cells, thrombocytes, which are the blood clotting cells. It also has hemoglobin, which carries oxygen, which gives the erythrocytes their red color. So again, erythrocytes are your red blood cells, leukocytes, your white blood cells, thrombocytes, your blood clotting cells. All right, let's talk about some movements of the body. All the movements of the body, which we learned, the names of them, supination, pronation, flexion, extension, those. But talking more about how the muscles in the bones interact is all about a lever system. And so at any point where two bones come together is called a joint, okay? So the junctions between the bones are called joints, and they are classified based upon how much they move and what type of tissue binds them together. So the first one is called a fibrous joint, and fibrous joints are like the sutures of the skull. These are immovable. They do not move. And it's basically like, that's like the parietal and the temporal lobe coming together. That's like the occipital bone and the parietal bone. That's a fibrous joint. It doesn't move. Then we have a cartilaginous joint. These are things like your pubis, your ribs, your vertebrae, because they have a little bit of cartilage in it. Remember the pubis had that pubic symphysis, which is made up of cartilage. Remember the ribs have a little bit of cartilage. Remember the vertebrae has the discs of cartilage in between. So that provides limited movement. They can move just a little bit. The vertebrae move a little bit. The ribs move a little bit. The pubis moves a little bit. Then we have synovial joints. These are most joints of the body. They allow for free movement. So, your elbows, your shoulders, your hips, your knees, those things. Those are all synovial joints. Some of them have menisci, which are the shock-absorbing pads, and other have bursa, which are fluid-filled sacs. So meniscus, you hear about that a lot in knees, people tearing their meniscus. Meniscus is a shock-absorbing pad. It's made up of cartilage, and then the bursa are these fluid-filled sacs. I always think they look like water balloons. They look like mini water balloons, and they kind of are used so that they can, joints can move around freely. These synovial joints are classified by their shape and by the movement that they do. These, if you look on page 165, these joints right here are all explained there, and take a look at them and take a look at that chart. All right, some problems that happen with bone. One, bone cancer. Obviously, active osteoclasts destroy the bone in bone cancer. So basically they're having these osteoclasts multiply at an alarming rate, and then they end up destroying the bone. There's something called cleft palate, and that's where you have the palatine process of the maxilla, which is around like the roof of your mouth, is incomplete at birth. So that's usually, you can see that it almost looks like their lip is malformed or something like that, and that's called a cleft palate, and that's something, like you said, that happens at birth. Spina bifida, that's when the laminae of the vertebrae fails to unite. So basically what happens is there's a hole. Instead of the vertebrae being completely, a nice little fortress for the spinal cord where it's all protected, there's like a little hole that can happen, and because the vertebrae is not completely formed. Obviously, a hip fracture or any fracture at all sometimes happens in the elderly a little bit more often because of older people's bones are a little bit softer, not as hard and healthy as younger people. But a hip fracture happens a lot in elderly people when they fall, and it usually happens right in the neck of that femur. So here's some pictures. You can see here's that cleft palate. That bone is not formed at the top there. This is spina bifida. You can see that that there's not a complete formation, so then all the fluid from the spinal cord can actually come out and form a little cyst here on the back. And usually you have to have surgery just to close this off, because we don't want anything to happen to the spinal cord. All right, you might hear about discs in people. They talk about in between their vertebral discs, I herniated a disc, I ruptured a disc, I slipped a disc. They use a lot of terms there. But point being, what happens is if you have the vertebrae and then the disc, and then you have the vertebrae and the disc, and the vertebrae and the disc. Well, if this disc gets out of control, it can actually push on a bunch of nerves, causing a lot of pain. So sometimes they have to have surgery to remove the disc. Sometimes they have to remove a part of the disc. Sometimes it relieves itself over time. But the disc, basically the problem is that these discs push on a nerve, causing burning, tingling, numbness, pain. Osteoporosis, that is the loss of bone volume, usually happens in older adults, particularly females. So they can sometimes cause spontaneous fractures, typically happen in white females past menopause because their estrogen is so low. And at that point, you need estrogen to absorb calcium. So you can drink all the milk you want and think, oh my goodness, I'm taking calcium, I'm doing good for my bones. But if you do not have enough estrogen in your body, it is not going to absorb the calcium. And that's what happens with these older women past menopause. Their estrogen goes down, and therefore they cannot absorb the calcium, and therefore their bones get really crappy. Arthritis, arthro means joint, itis means inflammation. So the word arthritis means joint inflammation. Basically, it just means that that articular cartilage is damaged there. Usually at the ends of bones. Over time, older people can get it just from wear and tear on the body. There's a special kind of arthritis called rheumatoid arthritis. You can see it in this picture here. Typically, if somebody's joint is kind of stuck in a certain position or something like that, you can see that that's rheumatoid arthritis. It can be caused from an illness. One of them that causes it is salmonella. So people who have contracted salmonella sometimes can actually develop rheumatoid arthritis.